Okay, now we're going to continue on our lesson. Number 13 has y sine 1 over y equal to 1 minus xy. And remember, we're doing implicit differentiation on this. And on this one, we're going to have to use the product rule. So we're going to copy down the y, then take the derivative of sine of 1 over y, which is cosine 1 over y. Then, if you need to, over to the side, remember 1 over y is the same as y to the negative 1. And when you're taking your derivative, that'd be negative y to the negative 2, which looks like that. And so that's what we're going to need over to the side when we take the derivative of 1 over y. So we get negative 1 over y squared. Now that's not part of the cosine. That's actually going to end up going in front. And then also remember that we need our y prime. The next part is the derivative of y is y prime, and then you keep your sine 1 over y as it was. So that takes care of the left side of the equal sign. We had to use the product rule and needed to close the parentheses or bracket right there. Okay, so the derivative of 1 is 0, and again you need to use your product rule. You can keep your negative x the way it is and then take the derivative of y, which is y prime. And then also you're going to need to have the derivative of x, which is 1, and so then you're left with negative y. So that's your first line. The next step is we're going to want to move our terms over and distribute. And so we have y prime factored out from here, and we're left with cosine 1 over y. Then this y cancels out with the squared part, so you're going to have negative 1 over y. And since we factored out the y prime, we're left with sine 1 over y. And set that equal to negative x y prime minus y. Okay, so what we want to do next is bring this y prime term over also and continue factoring out. So we get y prime, and then I'm going to move this to the front, negative 1 over y cosine 1 over y plus sine 1 over y. Then this is going to be plus x. It would have been plus x y prime, but we're factoring out the y prime, so just plus x, and then equal to negative y. So then at this point we want to divide, and so we have negative y on top and then all this on bottom. But this part is getting kind of complicated with having a denominator that's itself a fraction, so we want to multiply by y over y. And so I'm going to multiply by y to my numerator. I'm also going to multiply by y to the denominator, which is this. Negative 1 over y cosine 1 over y plus sine 1 over y plus x. So this turns into our answer, which is negative y squared over, and then this part cancels, so you get negative cosine. They're going to put that in the back, and they're going to put the positive sign in the front, and it's y times sine. And then we also still have a xy term at the back. So again, that's from distributing the y times this, the y times that, and the y times this. So the y times all three terms turns into this. And that's our answer. So again, we distributed the y times the cosine term, the y times the sine term, and the y times the x term, and we got this. Okay, number 15. Okay, so on 15, we have e to the 2x equal sine x plus 3y. So what we want to do on this is take our derivative of e to the 2x. So we bring the 2 in front, and we still have e to the 2x. And then for this side, we're going to have 1 plus 3y prime. So that's basically from taking your derivative of x as 1 and the derivative of y as y prime. So you have that. And then the derivative of sine is cosine. And then you have your your x plus 3y. So what we basically did was the derivative of this expression is cosine of this, and then you got to take your derivative of the inside, which we just put in the front with parentheses around it. Okay, so here we're going to start trying to solve for our y prime. We're going to have this part, 1 plus 3y prime equal to, this is our numerator, 2e to the 2x over this, which is cosine x plus 3y. Okay, so now at that step, all we have to do is subtract 1 and then divide by 3. So we get 2e to the 2x minus 1 over 3 cosine x plus 3y. Oh, I see what they did. So what they were doing was they did the minus 1 to the side, and then in order to get a common denominator, they had to put the cosine. So they have 2e to the 2x minus cosine x plus 3y So that's from negative times that all over 3 cosine x plus 3y. Okay, so there's your answer for that one. Our next one, number 17, we have theta to the half plus r to the half equal 1. So when we take our derivative of theta to the half, it's 1/2 theta to the negative a half. And now when we take our derivative of the r to the half, it's 1 over 2 r to the negative half. But now you need r prime. You could either put r prime or you could put dr d theta. Either of those are the same. And then equal to 0 because the derivative of 1 is 0. So what this turns into is the r prime in front, and then we'll turn this into 1 over 2 squared root of r. Then move this term over, negative 1 over 2 squared root of theta. Now we're at the point where we want to either think of dividing by this whole thing or simply just multiplying by 2 squared root of r to both sides, which I think would be the easiest thought process. So we're going to multiply by 2 squared root of r, and this gives you negative 2 squared root of r over 2 squared root of theta. And that gets us very close. Now we just cancel our 2's, so we get r prime equal negative square root of r over square root of theta. Okay, so that's several of that type problem. Now let's do one with second derivatives. So the problem is the problem is number 19 says x squared plus y squared equal 1, which is the equation of the circle with radius 1. And when we're taking our derivative of this, the derivative of x squared would be 2x, the derivative of y squared would be 2y, and don't forget your y prime. And then the derivative of 1 is 0. So now we're going to solve for y prime and subtract 2x, and we're going to divide by 2y. So this basically ends up with negative x over y. Now we need to find the second derivative, and so to get that, we're doing our y double prime, and we're going to use our quotient rule. So we take v, okay, remember it's u over v. Remember it's v over, well, v times u prime minus u times v prime over v squared. And so that'd be the y times negative 1 plus, okay, it's minus u, so minus a negative x, which is plus x, and then we put our negative x over y. So that is our u term times our v term, and this is over y squared. So y times negative 1 plus x times y prime. So this part is y prime, and we're basically plugging in negative x over y right there, because we already knew y prime. Okay, so then to simplify this, it turns into negative, well, we're going to multiply everything by y over y. And so this turns into negative y squared minus x squared over y cubed. So then we basically want to replace x squared. Remember, x squared plus y squared equal 1, so x squared is 1 minus y squared. So what we need to do is substitute that in for here. So we're going to have y double prime is negative y squared minus parentheses 1 minus y squared all over y cubed. So then we do our last step, negative y squared minus 1 plus y squared, which cancels the y squared terms, and so you get negative 1 over y cubed. So basically your negative y squared, positive y squared cancels. Okay, so that's an example of one with the second derivative. The one we're going to do next is on slope, tangents, and normals. Slopes, tangents, and normals. So this is number 31, which is x squared plus xy minus y squared equal 1, and the ordered pair given is 2, 3. So what we want to do on this is verify that the given point is on the curve and find the lines that are tangent and normal to the curve. So our first step is get our derivative. So the derivative of x squared is 2x. Then we do the product rule for this part. So we get plus derivative of x is 1, so we just get y. And then we do plus x times the derivative of y, which is y prime. And then we take our derivative of negative y squared, so that's negative 2y, y prime, and set that equal to 0 because the derivative of any number is 0. Now we want to factor out our y prime, and so we get x minus 2y on this side, and we want to move everything else on the other side like we did earlier, so negative 2x minus y. So what this gives us is negative 2x minus y in our numerator and x minus 2y in our denominator. Okay, so now we have our first derivative. Now what we want is the slope of the tangent line m with respect to the point 2, 3. So we're going to have negative 2 times 2 minus 3 over 2 minus 2 times 3. So this gives us negative 7 over negative 4, which is positive 7/4. So that means the equation for the tangent line is y minus y1, which is 3, equals 7/4 parentheses x minus 2. So when we distribute, we get 7/2, and then add 3. So this is minus 1/2. So that's our equation of the tangent line. So we did 7/4 times x is 7/4 x. 7/4 times negative 2 is negative 7/2. Then we add 3 to both sides, so we get negative 1/2 for your y-intercept. Then for your equation for the normal, this would be y minus 3 equal, remember the whole difference between the tangent and the normal is you need the opposite reciprocal. So if our original slope is 7/4, our other one would be negative 4/7. And so we're going to have negative 4/7 there with x minus 2. And then we just want to distribute. So y minus 3 equal negative 4/7 x plus 8/7. And then add 3 to both. And so we get 29/7. Okay, so that's an example problem with slopes, tangents, and normals. That's where we're going to stop.